Namaskar children. Since you've missed your class today, here are a few questions which we would have otherwise worked out in class. This is question number 12 from exercise 5. The basic introduction to the concept of bearings has already been given in class, so this is a continuation of the same. For the points P 2,5, Q 5,1 and R 0, -3, calculate the angle PQR. Now this is a question wherein the diagram is not given, but because the coordinates are given, if we make a rough sketch, it will become easier for us to comprehend the question and thereby solve it. So there goes the basic rough graph which we can use. Over here, the point P has coordinates 2, 5, so 1, 2 and 5. I've already marked a point. So maybe we can label this as the point P. Point Q has coordinates 5, 1. So this is the point Q with coordinates 5, 1. And point R has coordinates 0 and -3. So this is approximately where the points would be placed on the graph. We need to calculate angle PQR. Now in order to do that, let us first join the points. So that's P, PR and PQ. Now in order to find out this angle PQR, we will actually have to look out for right angled triangles so that we can then apply the trigonometric ratios. Alright, so if I were to complete this right angled triangle over here, the coordinate of P are given to us as the x coordinate of P is given to us as 2 and the x coordinate of Q is 5. Now 5 minus 2 is a 3, so which means I can conclude that this distance will be 3. Similarly, I can say that the distance on the y coordinate is going to be 4. Now over here, suppose if I name this angle as y, I also complete the right angle triangle onto the other side. So which means we just extend this line like that and complete the right angled triangle there. So if I name this angle as x, along this the coordinate is going to be 5 and over here the distance is going to be 4. So from this diagram, suppose if I talk about this triangle, the angle y, we can say tan of angle y will actually equal 3 over 4 because that's the way the tangent ratio goes. So which means I can say y is equal to tan inverse of 3 over 4. Similarly, if we consider this triangle, I can say tan x will be equal to 5 over 4. So which means x will equal tan inverse of 5 over 4. Now we can use our calculator to find out the angles y and x. Y comes out to be equal to 36.8 to 1 decimal place. And x comes out to be equal to 51.3. So which means the required angle, for us the required angle is angle PQR, which by looking at the diagram we can say will actually be equal to 180 minus x plus y. So which means it's going to be 180 minus 36.8 plus 51.3. So PQR, angle PQR will have the measure of 91.9 degrees when rounded off to 3 significant figures. And that's what the answer is. Alright, let's look at another question. The angles of an isosceles triangle are 66 degrees, 66 degrees and 48 degrees. If the shortest side of the triangle is 8.4 centimeters, find the length of one of the two equal sides. Now here again, let's start with a diagram. So there you go, that's the isosceles triangle. Since these two sides are equal, the base angles will also be equal in measure, which as per the question are 66 degrees. So both these angles measure a 66 degree and this angle is the 48 degree measure. Alright, further the question says the shortest side of the triangle is 8.4 centimeters. Now needless to say, the shortest side is actually going to be the side opposite to the shortest angle. The shortest angle is 48 degrees, so which means this is the side which is opposite, and this side will have a measure of 8.4 centimeters. Maybe we can just label the triangle because it then becomes easier to refer to the triangle. Alright, we need to find the length of one of the two equal sides. So in other words, we need to find out the length of AB, which is also equal to AC. Now here there is an important property of isosceles triangles which you've learnt earlier, and that's the property which is going to be utilized. If I were to drop a perpendicular from the vertex A onto the base BC, this point will be the midpoint of the line BC. So which means these two measures will be equal. So if I could just separate out this triangle, maybe we can call this point as point D and separate out that triangle from the main figure. We're separating out only so that it's a little easier to understand and take the question forward. This is a right angle. This A, D, C. So DC will then have a measure of 4.2 centimeters, half of 8.4. We know this angle is 66 degrees. And we need to find out AC. Now AC, needless to say, is the hypotenuse for the triangle, and the side DC, which we already know, is the adjacent side. So which means the ratio which we need to use in this case is the the cos ratio, because cos theta is equal to adjacent divided by the hypotenuse. So cos 66 degrees will equal DC over AC. So which means AC will equal DC over cos 66 degrees. Or in other words, it will equal 4.2 divided by cos 66 degrees. Again, you can use your calculators to get the answer. My calculator says AC should have a measure of 10.32609. I've taken the exact display of my calculator. Let's see whether the answer is correct. Alright, there it is. Because rounded off to 3 significant figures, that is what the value of AC becomes. Let's move on to another question now. So let us look at this question now. A rocket flies 10 kilometers vertically, then 20 kilometers at an angle of 15 degrees to the vertical, and finally 60 kilometers at an angle of 26 degrees to the vertical. Calculate the vertical height of the rocket at the end of the third stage. So the diagram is very important here again. I've made a rough sketch of the diagram which we can use. So if we say this is the starting point, this is the first point where the rocket is at the first stage, then it reaches point B, followed by point C. Let us just put in to the diagram whatever is given in the question. The first angle is given to be 15 degrees, so that's a 15 degree. This is a 26 degrees. So if I label this point as D, what we need to find out is the measure of CD. Alright, as we've always done, we need to extrapolate the diagram to get right angle triangles so that we can apply trigonometric ratios. Now the final length CD is actually going to be the sum of this plus this and the length this. As far as this length is concerned, we are given in the question that this is 10 kilometers. The second course of the rocket, this value is 20 kilometers. Then is the third course wherein this is a 60 kilometer. And let us get our angles into the right angle triangles. This is a right angle triangle, that's another right angle triangle. So over here, if this measure is 15, then this obviously is 85 degrees. And we have a 64 degree here. Alright, so as far as this length is concerned, this is obviously going to be equal to 10 because geometrically it will be equal to the measure of AO. Similarly, for this length, if I can find out this side of the triangle, I would have the answer. So if I label this as, this point as E, when I consider triangle ABE, I know the measure of the hypotenuse and I need to find out the opposite side. So which means we need to use the sine ratio. So sine 85 degrees will equal, let us just call this x for convenience because it then becomes easier, will be x over 20. So which means x is equal to 20 sine 85. So by the calculator, this value comes out to be equal to 19.923. Similarly, let's call this distance y. So over here, in order to find out this, if I label this as point F, I'm looking at triangle CBF. And here, again, sine 64 degrees will equal y over 60. So y is equal to 60 sine 64. Which by calculator comes out to be equal to 53.927. So the final length of CD will actually be equal to 10 plus x plus y, which by the display of my calculator comes out to be somewhere approximately to 83.251. Alright, so that does match with the final answer. So that is what the vertical height of the rocket will be in the last stage. Let's move on to the last question for today. It's quite an interesting question. A hedgehog wishes to cross a road without being run over. He observes the angle of elevation of a lamppost on the other side of the road to be 27 degrees from the edge of the road and 15 degrees from a point 10 meters back from the road. How wide is the road? If he can run at 1 meter per second, how long will it take to cross? If cars are traveling at 20 meters per second, how far apart must they be if he is to survive? Now, too many parts into the question, but let us take it up part by part. So the first thing, of course, is the diagram. So you need to understand this is basically the width of the road. So which means maybe I can call this as L. So that's my LB. Maybe this is the point A. So initially the hedgehog is at this point and then he moves 10 kilometers away. So this is 10 kilometers. Maybe I can call this point as H. And according to the question, the angle of elevation initially is 27 degrees. And when he moves 10 kilometers backwards, the angle of elevation changes to 15 degrees. Actually, it will become easier if we were to first separate out the triangles from this entire diagram. So that's the way it is. So I'm going to label this because it becomes easier. This is initial point A, point B, point L. So this is the tip of the lamppost. This is where the hedgehog is initially. This is the tip of the lamppost. This is the bottom part of the lamppost. And this is the point when he has moved 10 kilometers. What the question wants us to find out is actually the width of the road, which is AB, right? So this is a 27 degrees. Over here, that's 15 degrees. Alright, so here again, I have two right angle triangles to work with, and in both the right angle triangles, LB is common. So let us consider the first triangle. If I consider the first triangle, which is triangle LAB, I can say tan 27 degrees. We know the tangent ratio will equal LB divided by W, which is the width of the road. So in other words, I can say LB will equal W tan 27 degrees. Similarly, if we consider the other triangle, which is triangle LHB, we can say tan 15 degrees is equal to LB over, this becomes W plus 10 because we have this extra 10 kilometers added there. So LB is equal to W plus 10, the brackets are extremely important, into tan 15. So we can basically equate the value of LB from both the places, which brings us to W tan 27 degrees is equal to W plus 10 tan 15 degrees. This can be solved like a linear equation, and the final value of W comes out to be equal to 11.1 meters when taken in three significant figures. So which means we know that the width of the road is 11.1 meters. So that's the answer to the first part of the question. That is, how wide is the road? Alright, now this for the second part, if he can run at 1 meter per second, how long will he take to cross? So this is a simple question of speed, distance and time. We know speed is always equal to distance travelled over time taken. Here we need to find out the time, so we can say time is equal to distance travelled by the speed. The distance travelled is obviously the width of the road, so that is 11.1, and the speed is given to be 1 meter per second. So which means the time taken will be 11.1 second. So that's the answer to the second part of the question. And finally, if the cars are traveling, so which means cars are traveling across this road and they're traveling at a speed of 20 meters per second. So we have the speed as 20 meters per second. How far apart must the cars be so that he is able to cross? Now he'll be able to cross if he is able to cover this distance of 11.1 meters and the cars are moving at a speed of 20 meters per second. Now the time which he takes to cross the road is actually 11.1 second. We know from the previous part that this is the time which he takes to cross the road. So we need to find out at what distance should the cars be so that he can survive. So basically again it's the same speed, distance, time question, but here we need to find out the distance. So distance is equal to speed multiplied by time. So 20 multiplied by 11.1, which is 222. So which means the safe distance between the cars should be 222 meters so that they don't hit the hedgehog and he is able to survive. Alright, so that's all from the explanation that I needed to give. The answer which you see over here is incorrect. That's from taken from some previous question. The final answers are 11.1 meters, 11.1 second and 222 meters. So please cross check with your textbook for the answers. Now it's your turn. These are your homework questions. So complete them by tomorrow and we shall further take ahead the exercise in tomorrow's class. Thank you.